Hello, everyone. Welcome to RAND's webinar. Thank you all for attending our webinar today on the critical issue of parking structure safety and local law compliance in the wake of the recent garage collapse in Lower Manhattan. I'd like to introduce Jimmy Vignola, RAND's structural team leader, as well as Jason Damiano, a senior structural engineer at RAND and qualified parking structure inspector, also known as a QPSI. Jimmy, would you like to take it away?
Thanks, Michelle. My name is Jimmy Vignola. I am the structural team leader at RAND. A little about myself to get started. I have about 19 years experience, licensed in New York and New Jersey. I'm also a model law engineer, as stated by NCES. So basically that means I can meet qualifications of licensure in any state in the country. I worked for 15 years experience before RAND, have experience with buildings, new construction, large scale projects for public agencies, and I've been here for 5 years. Jason is also licensed in New York, and he is an excellent engineer, also one of our best project managers here. So I will open up the presentation with a little bit more about RAND engineering. We have been around since 1987, so about 36 years, a little over 100 employees, 26 licensed engineers and architects, many more unlicensed associates working in engineering and architecture. RAND is best known for our facade team. You see, we've done 4,100 facade inspections in 36 years. So I think we are the second biggest facade company in New York City. So a lot of experience there. We are a full service engineering and architecture firm. We also have an in-house expediting code and zoning team to help with all of your needs in terms of filing with various city agencies. The structural team, architectural team, mechanical team, the facade team, forensics to do building surveys and help with capital planning. All of our teams have project managers. So after designing our projects, we will help with bid solicitations, bid reviews, can help write an AIA contract between building owners and contractors. And then we will perform construction administration, make regular site visits, RFIs, review payment certifications and change orders, all of the above. We try to do it all here. So whatever you need, please feel free to call any of us at RAND. I'm pretty sure we can help you. Jason and I are on the structural engineering team. So besides parking structures, we also have a lot of experience with sidewalk vault repairs and all of the various filings that you need for that. We do work a lot on roof deck feasibility studies, another very popular service that we provide, as well as repairs, alterations of all kinds. So today's presentation is on parking structure safety. The impetus for this program was this parking garage collapse in Johnson City, upstate near Binghamton, New York in 2015. You could see from the photos, the top level collapsed, caused a lot of damage. This incident pushed New York State to pass a new law that required all parking garages to be inspected by a qualified engineer every 3 years. New York City, since we have our own Department of Buildings, didn't immediately follow the law, sat out a few years until the city was able to develop their own regulation. But in 2021, New York City, joined, the party here. If you have any need for parking structure inspection outside of New York City in greater New York State, we of course can do that also. All parking garages need to have a permit to operate in the state, so you needed to have an initial inspection. All garages should have had that initial inspection already. We'd be in the second or maybe even third cycle for some of these garages. Again, one due every 3 years. all parking structures are required to be inspected. There's exceptions for single family homes, townhouses, and parking lots. In New York State, since the inspection reports have to go to one of various towns or villages, there are local requirements that somewhat vary between the different municipalities. The program involves us submitting a condition assessment report. This is similar to the city. We'll get in more detail here. Primarily, we need to identify unsafe conditions or conditions that require repair. We make recommendations, including timeframes. And we want to make, it also requires us to submit photographs and recommend maintenance measures that should be implemented in the next cycle. In New York City, the program is called the Periodic Inspection of Parking Structures. It's PIPS, very similar to the FISP moniker that I'm sure many people are familiar with for the facade inspection program. We also see this program referred to a lot as New York City Local Law 126 of 2021. That was the initial moniker that most people were using. Local Law 126, not to be confused with PIPS. Local Law 126 was actually the local law that established the new 2022 New York City Construction Code. So that local law included a lot of new regulations, building code, plumbing code, mechanical code, energy code, all of the above was included in this local law. Part of that local law 126 was this Article 323, which requires, established the outline of the parking structure program. DOB, now that we are, well into cycle 1A, has started referring to this as PIPS. We are adopting that, and I think over the next few years, people will start dropping the local law 126 moniker, and we'll be referring to it as PIPS. The parking structures in New York City that need to be inspected include any building or portion of building used for parking. That includes parking structures in basements. It includes standalone garages, including open parking garages. So some garages have only partial exterior walls, and they're basically open to the exterior elements. Those are also subject to this inspection. What is exempt is a parking lot, such as the one in the picture, even if it does have the car lifts, mechanical car lifts. Those are exempt, no requirements. Garages with 3 or fewer cars, exempt, as well as auto body repair shops and showrooms. And also, we recently learned that loading docks are exempt. If you have a loading dock and you're worried about that, that is exempt from this. All parking garages have to be have their initial report filed in the next 6 years. Cycle 1 started in 2022 last year. It goes through 2027. That's the 6 years. You then have subcycles, 1A, 1B, and 1C. We are 3/4 of the way through subcycle 1A. That's in the bright red. So any parking structure that's located south of 59th Street or in the Upper West Side is in subcycle 1A. Community districts 1 through 7. Those reports need to be filed by the end of this year. Cycle 1B will start in January. That's Brooklyn and the rest of Manhattan. That's kind of the middle shade there. And the lightest shade is 1C, Bronx, Queens, and Staten Island. That'll kick in 26 and 27. And then in 28, we will start all over again. New construction is subject to this regulation. It depends on the time of the first CO or TCO. If the 6-year deadline falls within the initial filing period, then you do need to file within those first 6 years. But if that If 6 years extends past your initial filing cycle, then you can wait till cycle 2 to file. So it depends on when the building, when that CO or TCO is sent. If you have a question on new construction, you can call us. We'll help you through it. Matter of a couple days at the end of the year or a month might give you 6 more years to file that first inspection. So the regulations again started 2022. You have to be inspected every 6 years. The inspection needs to be done by a qualified parking structure inspector, such as Jason. Here, the QPSIs, you need to be a licensed engineer. You need to have 3 years of experience with parking structures. You have to be certified with DOB. So Jason has, submitted his application to DOB, and then after reviewing his qualifications, they actually schedule an interview and they ask very pointed questions about, how you would handle certain situations. There's actually people at the DOB parking structure forensic unit that are vetting you, make sure you really are knowledgeable about parking structures, common problems and how to fix them before you get that QPSI designation. So if you don't go to RAND, which I don't recommend, make sure they have QPSIs. And then the QPSI oversees the process. The final result is submitting this condition assessment report, which the bottom line is this parking structure classification, safe, unsafe, or the intermediate and most common safe with repairs and or engineering monitoring, which we call SREM. The process of inspection basically entails review of documents. We love getting structural drawings. If you have the original structural drawings of your building, it makes this process a lot easier for us. Often we don't. If you have some other alteration, repair, program drawings that you've done, that's also helpful. So send us any documents that you have. We also review violations. We can, or we will review FISP reports in some situations where the facade is included in the inspection. We'll touch on that a little bit later. And then the inspection process requires that we review previous reports on the parking structure. So here in cycle 1, we're not doing that, but when cycle 2 starts, we will be looking for the cycle 1 reports and we compare and contrast what was required, make sure it was done, just kind of check up on the results of the first one. The facade of the parking structure does need to be included in the inspection if the parking usage in the building exceeds 50% of the total square area, regardless of height. So if you have a 4-story standalone garage in Manhattan, that facade also needs to be inspected. The typical parking garages that are in the basement of a building in Manhattan, we are not inspecting the facades there. But occasionally we run into one that requires a facade, and of course, that makes it more labor intensive. It makes it a larger study for us. The inspection must includes both visual examination and physical examination. Typically, we do an initial walkthrough with the QPSI and some of our other associates. That's the visual part. We're planning, we come back to the office, we use what we see for planning, how much physical examination, where, and the type that we need. The regulations require that we do physical examination on 10% of each type of structural element. That could include sounding. I'm getting a little ahead of myself. So here's the visual walkthrough performed by our team, and here's the physical examination. The 10% of each element. Mostly we are doing sounding. We have these tools that allow us to, just sound floors and columns and overhead structures without needing, too many ladders and hammers and too much assistance. So we do a lot of our physical examination this way. We can even do it sometimes during the initial examination, the initial walkthrough, kind of doing both at once. But depending on the conditions that we encounter, we may need to do more intensive physical examination, including probes, GPR scans, material testing. All of those things are in play, but most commonly, you're going to get a good amount of sounding by our team. Once we complete visual and physical examination, it's then time to put the report together. DOB has given us a very specific list of things that the report must include. We have to describe the structure's gravity and lateral load resisting systems. The drawings help with that, although we can do a lot of it visually. We have to, of course, describe the existing conditions. We have to give them photographs, and we have to provide itemized recommendations for each item that requires repair, all of the SREM items. We also need to include, that review of the previous cycle. And a key difference between PIPs and FISPs that you're going to see is that in this program, we have to include a structural stability analysis, both of a typical scenario and a worst case SREM condition. So we are actually putting together engineering calculations and submitting them to DOB to show that the structure is capable of supporting the required loads, both in its unaltered state, and if there is an area with significant deterioration, we need to analyze that and show that yes, even that significantly deteriorated area is capable of supporting the loads that are imposed. And if it's not, well, it's not SREM. That would be an unsafe. Luckily, so far we haven't found any of those. We also need to include floor and ceiling plans for each level. We have to do 2 sets. The first set is going to show where we did our physical examination. DOB is checking the 10% here, and then we perform a second set, submit a second set of drawings that show the required work areas. Here, this plan, showing cracks, we're showing areas that need to be patched. So there's structural analysis and also CAD work involved in these reports. Another thing we have to do is we have to develop a unique annual observation checklist. This is specific to your structure. We try to give you a rundown of what should be checked in the years between the 6-year inspection cycle, right? It's required for us to give you the checklist, and then it is required for owners to perform this annual observation using the checklist in between years. You don't need a QPSI to do it. You don't need a PE to do those in between years. We try to set this up so that it's easy to do. You can do it with your staff, but of course we're available to help. So we submit this, and then you have to use it in the following years. Report has to include this classification: safe, unsafe, and SREM. If it's unsafe, it needs to be repaired immediately. Safe structures require no action, and SREM actions are somewhere in between, right? Not immediately and not none. They require repairs, and we have to give a specific time frame: 1 year, 2 years, 3 years, depending on the severity of the condition. It's important to note that SREM conditions, that if they are not fixed when we come back 6 years later, they are automatically unsafe. We can't call them SREM again. So if you have a SREM building, it's very important to get the repairs done before we come back in 6 years. Unsafe conditions need to be repaired immediately. We also are supposed to inform the DOB, and we have to take actions to protect public safety. That could be closing a couple parking spaces. It could theoretically be closing the entire garage. We have not run into that, but the possibility is out there. You have 90 days to correct the conditions. If for some reason we can't get it done in 90 days, the QPSI can file for an extension for another 90 days. As long as we're on top of it, we're doing something, we're showing progress, we can continue to get extensions. After they're all done, QPSI has to come back again and certify that they're done. The unsafe conditions have been addressed, and the building is no longer unsafe. We would then submit an amended report to say that it's SREM or safe. So you'll hear these terms: amended report and subsequent report. The amended report, as I just mentioned, is specifically for going from unsafe to SREM. A subsequent report is to change some other aspect of the filing. Maybe we change you could go from SREM to safe, or maybe we could be, modifying, the time frame that is required to do the SREM repairs. Amended reports are critical if you get it unsafe, but subsequent reports, there's usually a little bit of play in there. Starting April 17th, this whole process to submit the reports has been moved to DOB now. We were sending, paper PDF reports for a while, and they were accepting them. That's all out the window. I assume most owners, property managers, somewhat familiar with DOB by now, because you have to go on them for FISP and also for any jobs, any alterations, repair jobs. Everyone's got to go on DOB now at some point to sign e-sign forms and pay filing fees. So all of that is now in. You can see on the right there, that's where you find the parking structure has been added to the menu a little bit below where you would find facades. There's filing fees. It's $305 for an initial filing, and further fees for subsequent and extensions. There are fees, penalties involved if you don't file on time. These are similar to FISP. They're going to ding you $1,000 a month. For late ones, failure to files, you get an extra $5,000 after a year, and failure to correct conditions, again, it's $1,000 a month. So important to stay on top of those. If you get a penalty, you want to challenge it, there is a process involved. You need a QPSI involved, and you need to do it within 30 days of receiving the violation. We can help you with that. So the next part of the presentation, I'm going to hand it over here to Jason. Jason can talk a little bit more about specific things that he is seeing on site as the QPSI. He's going to all of these. I work with him on the technical side, report writing. So the two of us basically overseeing all of the PIPS reports right now, coming out of Rand's office. And at this point, we have done. We did actually get one garage accepted by DOB. We have another batch that we're, in the objection stage, and we're giving them additional information, and another batch that, we've observed, but we haven't submitted the report. So we're about, 5 to 10 parking structures in here. So we thought, it would be a good time to have this presentation. We could actually share, what we're seeing, and also the feedback that we're getting from DOB, because that was the big question for us going into this whole process is, how were these conditions that we're used to seeing from our typical experience doing garage repairs for many years? What was the DOB gonna think of them? So now we've gone through that, and Jason is the point person for all of us. So I will turn it over to Jason, and he'll go through the rest of the presentation. Jason.
All right, thank you, Jimmy. Thank you for that overview. As Jimmy mentioned, I'm a senior structural engineer at Rand, also a qualified parking structure inspector. I've been at Rand about 12 years, and a lot of my work has been in parking structures over that time. I'm going to go through some common problems that we see in garages first. The number one problem, the item that causes the most deterioration in these structures is water and de-icing salts brought in by vehicles. The vehicles that park in these garages, they're outside in the elements, rain, snow, driving on the roads. In New York City, we salt the roads, so those water getting in via those means gets into the concrete. It causes deterioration. The salt and other chemicals that get in the water even further accelerates deterioration. So that's the number one source of issues in these garages. Another source of water is water infiltration from exterior sources. A lot of these garages are subgrade structures, which have foundation walls, and therefore on the other side of the foundation walls is potentially groundwater. Water can leak through cracks in walls, and once that water is in the garage, it not only does damage to the walls, but it can damage the parking surface as well. And a lot of garages that we've seen are also located below plazas or terraces, which creates another source for water to enter. The plazas and terraces need to be maintained, need to be waterproof, roofing membranes over them to make sure that exterior water is not getting into the garages. Once that water is in, like I said, there's really no way to avoid water getting in the garage, but once that water is in, we need to make sure it's getting out. The best way to do that is with a waterproofing membrane that keeps the water away from the concrete and gets it to the drains. But one of the things we see, a common problem, is either a lack of waterproofing or water that ponds or poor drainage. So these systems also need to be maintained. Another common condition we see in garages, especially those that are older and have been experiencing conditions for years, is previous repair attempts. If the sources of the water that I've spoken about above are not addressed, these previous repairs become areas that will accelerate in deterioration as the water continues to get in these areas. And then a final additional item that we often see is damage to and from other building systems. A lot of these garage spaces have mechanical systems installed in them, and those can both be a source of damage due to the types of moisture and condensation we see on those lines, but also they can be damaged by the types of damage we are seeing in these garages, just the same as the structure itself is. So moving on now, I'm going to get you into some specific conditions that we've seen. This is a pretty typical concrete parking garage. You can see the level of spalling that is occurring in the top side of the concrete structural deck. In this particular case, you can see the concentration of spalling is particularly strong around where the wheels of the cars are. As you can see, when a car pulls into this spot, the water starts to shed off the car. As it sits there, parks overnight, it all comes down and straight into the slab. Unfortunately, the other thing you can notice in this photo is that there is no waterproofing membrane on this slab. So what the water wants to do with the slight pitch in the slab is drain to that drain you can see in the photo on the left. Unfortunately, once the slab starts to crack and spall, the water is not able to make its way from the car's parking spaces to that drain. It's just going straight into the cracks and the spalls. And you can see the spalls have been severe enough in that photo on the right that we're actually getting exposed rebar, which is deteriorated. The other thing we see in this photo is when you see the spalls, you think of a localized issue that's specific to this area of slab. When you get to know the building, a lot of these parking structures are located below residential buildings. So these columns that we see in this photo are actually part of the building superstructure. These columns go all the way up 20 plus stories, supporting the residential building above. So this slab is actually serving two purposes. It is supporting the cars that are driving on it, but is also bracing these columns. This is a vitally important function, a vitally important purpose to the proper functioning of the structural system. The column is designed to span, whatever that 12-foot span is from floor to floor. If there is a localized failure of a slab, although it might seem like it's only a localized issue, unfortunately, if this slab were to collapse, you can run into a situation where the column is no longer braced. Once you have a column that's no longer braced, that's when you can see a progressive collapse of the entire superstructure, similar to what we saw downtown, but also in Surfside, Florida, 2 summers ago. That's definitely the worst case scenario. And when we saw this condition, we were concerned about it. So we proceeded with probes. We made sure that we got down to a depth of concrete where there was actually sound material. And we were able to quickly confirm that, the concrete wasn't unsound all the way through. And therefore we didn't need to install emergency bracing. But this is one of the main things we're looking for, is not just, is this a localized problem in your parking structure, but how does it tie into the overall building system? And these are other common problems. Like I said, garages are often located below terrace spaces. If those terraces, plazas are not maintained, that water can get into the terraces and then can go straight down into the garage. So this photo on the left is an example of an under-maintained terrace area located directly over a garage. That water goes in, gets in that slab, goes through it, goes straight into the garage, and it's just another added point of water infiltration deteriorating the garage. And on the right, you see a typical garage foundation wall where you're getting through wall leaks. Those leaks are likely groundwater. I go in some buildings where they say the leaks are much worse in situations where they get heavy rain because the groundwater kind of swells up. So once that water is in, it's not only damaging the foundation wall, but it also gets into the parking structure slab as well. Another thing that we commonly see when we walk in garages is these types of protection that are installed. Unfortunately, these are, the lowest measure that is typically done to prevent water from dripping on cars or debris from falling on cars. They're obviously not addressing the source of the issue. Source of the issue is water getting through the slab. So in the condition on the left, some shielding was installed at the ceiling, likely by a garage operator or local building staff, and it prevents water from dripping right on the cars, but it doesn't stop the concrete slab from deteriorating. Unfortunately, it might be a temporary stopgap, and therefore the staff on site feels like they're handling it, everything's fine, but that concrete is continuing to deteriorate. And it might be a situation where they don't feel the need to bring an engineer in. So, we always recommend avoiding these types of situations. And then the photo on the right is an example of, a ceiling that was leaking, very similar situation. Instead of just installing shielding, they applied a waterproof coating to the crack in the slab. Unfortunately, what happens when you apply a waterproof coating to an overhead condition is the water, and you don't address the source of the water is still getting into the slab. It is still able to do damage, but once it gets in the slab, the crack is now sealed from below. It is trapped in the slab. So it will actually accelerate deterioration. And you can see in this photo, there's already spalling concrete and deteriorated rebar in this case. So this is one of the things that we always point out to avoid, but they are very common issues that we see in these garages. Another common items, as I mentioned earlier, are mechanical systems. On the left is some ductwork, and on the right, piping. So on the left, there's likely that ductwork likely has a penetration somewhere to the area above. That penetration may not have been properly sealed, and it causes deterioration of the entire ductwork system. This is something DOB is making us look at. If there's loose material on that ductwork or it's not properly attached, this is something we have to note in our reports. And then on the right, this is actually a photo of the interior of a parking garage with a mechanical space over it. So there's no exterior source of water and there's no cars driving over this location. It's actually just, damage being caused to the concrete structure by the mechanical systems, which are, leaking. There's insulation on these pipes, but they're not fully insulated. This type of moisture causes the same damage to your structure as any other source of moisture. So it's just another thing that we see in these garages and another thing to keep an eye on. In addition to your typical mechanical and plumbing systems, we also have, electrical conduit lines. All of the garages that we go into have lighting. Unfortunately, a common practice at one point in time was to actually embed these conduits within the thickness of the structural, concrete decks that we see in the garages. Unfortunately, those conduits are just as prone to corrosion as any other type of metal in the slab. As you can see in that photo on the left, the conduit is completely deteriorated. You can see the wires within it. This is also something that causes problems in the slab because unlike rebar, which is solid and tied to the structure, the conduit actually has space inside of it. So once water gets in the conduit, it can actually travel along the conduit and damage a new area. And the other thing that's dangerous about these embedded conduits is they can look like just rusted rebar, deteriorated rebar when contractors are doing demolition. So it's something contractors have to keep an eye on to make sure they don't use a jackhammer and jackhammer directly into a live wire. And then on the right is a typical surface mounted conduit line, and part of this parking structure's lighting system in the garage. Unfortunately, there's a leaking crack right in this area, and these systems are just as susceptible to the types of deterioration we see as the structure itself. And again, DOB is making us review these items. So just another common problem that we see. Now I'm going to talk more about the specific materials that we deal with. A lot of the parking structures that we see, almost all of them have at least some level of concrete installed. Some of them are reinforced concrete structures. Some of them are steel frame structures that have concrete decks, but most of the driving surfaces are concrete. The structural the structure supporting driving surfaces are concrete. Concrete is prone to cracks. Most of these types of structures do not have design joints in them. They are designed to span long distances, but cracks are a natural thing in concrete. Your typical shrinkage crack, you see them all over the place. You walk down the sidewalk, you might see them. Concrete is very prone to cracking. Unfortunately, once there's a crack, there's also a place for water to enter the structure itself. Once water is able to enter the structure, it can make contact with the steel reinforcing within the concrete. That causes the steel reinforcing to deteriorate. Once it deteriorates, it starts to expand, and it causes the concrete cover to separate from the rest of the concrete slab or concrete beam. This is a process called spalling. The actual concrete separates, and in this case was removed, showing the exposed rebar. But cracks and spalling are the two main items that we see in concrete slabs. Now I'm going to kind of walk through the life cycle of a typical crack. On the left, you can see a pretty typical, shrinkage crack that's has some water infiltration. You can see a little bit of evidence that water has been coming through. This is, the early stage of this issue. It hasn't started to spall. It hasn't started to, you don't see any serious deterioration, but it is something that if you address it right away and stop the source of the leak, your repairs will be much less. Then on the right, you see, the next example of a crack that, started off very similar to this one on the left, but it was not properly repaired. There was some repair attempt. It is obviously a larger spall area, and you can see the staining from the reinforcing because that reinforcing is even more deteriorated over time because of the amount of time that passed without, proper repairs and fixing the source of the water infiltration. When this happens, it just leads to a more costly repair. And as we go to the next slide, you can see on the left is an example of something that started as a crack. That epoxy that's applied from left to right was an attempted crack injection. It did not hold. Then they tried to do a spall repair, that gray box that's in the middle, and it continued to deteriorate again. They likely did not address the source of the water infiltration, and now you have an even bigger spall area that requires more repair, it costs more, and it's a potentially hazardous condition now that there are loose spalls in this area. And on the right is a photo kind of going through that entire crack cycle in one photo. At the top of the photo on the right, you have a typical kind of hairline crack. As it goes, it goes up to the top of the slab. As cars drive over it, water leaks on it. The water makes its way through the crack, and as you can see, about halfway down the crack, where it's a little bit more deteriorated, you start to see concrete spalling. That's kind of the next stage. And at the bottom of the photo, you can see concrete has spalled off the the rebar. The rebar is now exposed and it is deteriorating. So it's kind of the entire life cycle at once. But these are the typical type of common problems that we see in concrete, especially relating to cracks. And then the next slide, we talk about on the top of the slab, we see very similar conditions. The typical cracks in the slab, again, we see cracks all the time. It's not surprising, but if there's no coating, like there isn't in the photo on the left, the water can get straight into the concrete slab and start to deteriorate it both above and below. So on the right, we see that effect of spalling in a garage at the top of a slab. A lot of these slabs are designed to have top and bottom reinforcing. So the bottom reinforcing, you see when the rebar deteriorates, the spalls pop off on the bottom. On the top, the spalls don't really go anywhere because they're not, pulled off by gravity. So you just have a situation that can create trip hazards, potential damage to cars, and also is in need of repair. The other type of structural framing system that we often see in garages is steel framing. As I mentioned earlier, on the left, we see a photo of a kind of unique spall pattern in concrete. This is actually a situation where a steel beam is located under this slab. The top of the steel beam is deteriorating, and it's causing a very specific type of spall pattern along its top flange, and is in need of repairs. Steel beams deteriorate in the exact same way that steel rebar does. as water accesses the surface, it will start to expand as it corrodes, and this expansion causes, whatever surrounding the concrete, whatever surrounding the steel to expand and crack. So in the photo on the right, very typical condition of a steel beam encased in concrete. That concrete encasement is now cracking and at risk because that steel has started to deteriorate. This is both, initial cracking and starting to get to the point where it's spalling and potentially hazardous. The other thing that we often see in the steel frame structures is instead of concrete columns, you have steel columns. The steel columns are often encased in, masonry or concrete. One of the issues that we commonly find is that, especially when columns are encased in masonry, they might not be as tightly packed. So you don't necessarily see immediate evidence that the steel is deteriorating. So you can open up and kind of run into a surprise at how bad the steel is. On the case on the left, you can see through that steel column. In the case on the right, this is a pretty severely deteriorated column that was surrounded by CMU, but the encasement was concealing the damage to an extent. And then here's two more steel columns. The one on the left is encased in concrete. You can see the cracking encasement, and that area has been marked for repairs. And then on the right, you see a brick masonry encasement around a steel column, and you see a large crack going all the way up and down. As that steel has just expanded a little bit, the brick cracked all the way across. Now I'm going to get into a few specific cases based on feedback that we've gotten from DOB on the difference between SREM conditions and unsafe conditions. One of the things that we are trying to emphasize as we go through this is that, a lot of these conditions might seem fairly typical and, oh yeah, that's spalling, that's cracking, there's some water getting in, but there are differences between these different types of conditions, and it does sometimes take a trained eye to really note the difference. So in the case of this location, this is actually a situation where we have gone through the full DOB process. We submitted our PIPS report and we got feedback on it. So in our initial PIPS report, we submitted the photo on the left as a SREM condition. DOB did not accept this photo. They saw the unsound material, which we had identified in our photo and in our write-up. And they said that material looks like it's potentially loose. You need to do a further investigation in this area and submit a stability analysis. So we came back with a contractor, created the situation on the right. We removed, the unsound material, exposed the rebar. And when we exposed the rebar, we took measurements of the rebar to be able to perform that calculation that Jimmy mentioned earlier. So in this particular case, we had to provide a calculation of what this slab, what the loading condition on the slab is without any deterioration of the rebar. And then we need to submit another calculation of a worst case scenario, which is the actual rebar condition. So if the rebar is deteriorated by 10%, we need to do a calculation showing 10% less rebar and prove to DOB that this is in fact safe with repairs and is not an unsafe condition. So in this particular case, we submitted the stability analysis and the photo on the right, and DOB accepted it as a SREM condition. This is, kind of like the next stage of a SREM or unsafe condition. I just want to show here that it's not always quite straightforward. We can't always just look at it and know from a photo what the answer is. So in this case, any of the unsound material that looked like it was potentially loose has been removed in this case. We do see exposed rebar. That rebar is deteriorated to some extent. So the way to figure out whether this is an SREM or unsafe condition is not just via visual inspection. We have to perform the aforementioned stability analysis by measuring the rebar and showing that this condition can take the loads that it was designed for in its deteriorated state. So this is one where this is kind of a borderline SREM or unsafe, depending on the results of the stability analysis. It's not about just the the condition that it's in, but specifically what we find when we do those calculations based on the conditions. Just wanted to show that it's not always just that easy to look and give the answer based on what DOB is making us submit as part of this process. And then this is the final SREM or unsafe condition I'm going to go through. This is one that, unfortunately, we can look at pretty quickly and determine that is unsafe because of what we know DOB is requiring us to submit regarding SREM conditions. In this photo, see a pretty severely deteriorated concrete slab with all the, spalled material has been removed, but unfortunately, the rebar going up and down the screen in this photo is, almost completely deteriorated, disintegrated. What you see there is mostly just staining on the concrete from what's left of the rebar. So there's, no rebar to measure in that case. And the larger bars going from left to right in the photo, you can see are very thin. You can see how thin that particular rebar gets just to the left of the light on the right side of the photo. The rebar has reached a point where it probably lost, 75% of its section. We know by looking at this that there's no way we can perform a stability analysis that would show it can take the loads that it was designed for. So this is pretty easy to identify as an unsafe condition. But, that's the type of things that we're doing as a trained eye, qualified professional that, typical garage staff or someone who's in these garages is not going to be able to notice the difference between these things. The other thing DOB is making us note in these reports that I have noted on a couple of occasions is appurtenances. These are things like, roll down gates, guardrails, signs within garages. Anything that's attached to the structure needs to be reviewed. Things like parking lifts, stackers are not part of the appurtenances that we need to review. And next, I want to get into, what happened with last month's tragic collapse at 57 Ann Street. This was a 3-story parking garage. It was a standalone garage. There was no building structure over it. It was originally built in 1925. And when it collapsed, it tragically killed 1 person and injured 5. If you look at the photo, you can tell that there is, the slab collapse. That's called a shear failure, which means, the slab just couldn't hold the load anymore, and it just collapsed into the area directly below. One of the things I've been talking about are the typical conditions that we see in garages. Unfortunately, some garages will reach a certain point where the conditions aren't typical anymore. This garage had certainly reached that point where the deterioration was so bad that there were likely different kinds of signs. And this is one of the things that we want to emphasize is that in severe conditions, there are also other types of cracks beyond the typical shrinkage cracks that we see causing the initial issues in garages. But when a garage gets to the point where the structural distress is at a dangerous level, you will start to see flexural cracking and shear cracking that can indicate a potential collapse like this. So unfortunately, in this case, it is highly likely that the only people who ever accessed the upper level of this garage were the workers that had been in there for potentially many years. They weren't able to see the signs. They just saw this has always been deteriorated. But if a trained professional had been in there, they might have come to a different conclusion. You can avoid something like this from happening. So we really want to emphasize that you do need, an engineer. And what DOB is emphasizing via this program is that you really do need an engineer in these spaces to make sure the worst case scenario cannot happen. And then, in addition to, the obvious at 57 Ann Street, this building did have a violation dating back to 2003 for cracks, spalling concrete, etc. There's no evidence that a major repair program was filed for over the last 20 years. So unfortunately, not only was it bad enough to warrant a violation in 2003, it was never fully repaired. Conditions were able to keep getting worse over time. Like we talked about with the stability analysis, when you have a situation where the slab is deteriorating, the structure is actually getting weaker over time. That's what we need to, provide to DOB, and that was happening, over the last 20 years in the structure. And then, finally, the other factor here is that there was likely a weight capacity and overloading issue. The garage had extra lifts installed, which means that the loads in the garage were increased. So when you combine the fact that the original structure was never designed for extra cars, and then you factor in the fact that it's deteriorating and getting weaker, you end up with a situation where, unfortunately, the slab is just overloaded and it can collapse, and the worst case scenario can happen. This garage was particularly vulnerable also because it was exposed to the elements. Like we talked about, a lot of garages have plazas over them. Unfortunately, this roof level of the garage was completely exposed to the elements and all of the water and de-icing salts that are brought into the garage. So this is a case study in the worst things that can happen, and unfortunately, it doesn't appear that an engineer was able to get in there and make the proper recommendation. In response to this collapse, DOB has activated inspectors. As of May 15th, according to the New York Times, they have visited 187 garages. They've ordered 3 garages closed since that time and have partially closed 12 others. Their findings are very similar to what we've been finding, just to a greater extent, especially in these garages that are closed. The New York Times has also found that at least 25 garages had violations relating to the installation of lifts without a permit or excess occupancy. These are the exact things we just talked about in the collapse. These garages need to be maintained, but just one of the reasons for this webinar is DOB is making this a real point of emphasis now, for obvious reasons, but they also don't have the capacity to go into every garage in the entire city. So, that's what the PIPS program is for, to have us, qualified engineers going in these garages and making these assessments. The final thing I want to talk about is prevention and maintenance, because concrete and steel rapidly, deteriorate due to the external and internal from the cars sources of water and chlorides. These parking structures are always going to be in need of some level of maintenance, if not full structural repairs. So if you can keep up with inspections and maintenance, you can really reduce your overall costs over time, and obviously create safe conditions, which is really should be the goal of maintaining any garage. This is a chart commonly used in the industry to show the level of work and the cost that it entails. So at the bottom, you see a preventative maintenance program. Every time this deterioration reached the level of normal wear, this is a situation where a building owner is able to keep up with the repairs. The repairs cost less every time because deterioration is not able to accelerate to the point that they need structural repairs. Item B there, which is minor repairs, you get into a situation where you're just doing regular kind of low-level structural repairs. It costs more over time. You end up doing them slightly more frequently, but you're not in danger of collapse in that scenario. And then level C, major repairs, you can see how much more the deterioration typically accelerates. You have to do a major repair program every few years that not only costs a lot more, but it is putting people at risk. So those are the types of situations we look to avoid. And then finally, just want to go through some best practices for prevention and maintenance in these garages. One of the things that DOB is mandating here is implementing a routine inspection program, the every 6 years by a qualified professional, but also, as Jimmy noted, we are giving you an annual observation checklist to have that annual inspection performed. Another maintenance item is just fixing these minor defects, falls and cracks as they appear. Like we said, if water is able to get into the concrete via cracks, it's just going to keep getting worse. If you can keep up with repairing them and not doing a major repair program, every 20 years, if you can keep up with it, it's going to be much better. Also addressing leaks, make sure you are addressing the source of the water infiltration, because even if you do localized repairs, the water is still getting in to the garage, you're still going to run into issues. And then, in my opinion, one of the most important things you can do is install and maintain a traffic bearing waterproofing coating. often called a traffic coating system. These are essentially waterproofing membranes that are designed to be driven on because there is an inevitable source of water and de-icing salts that are going to come into the garage. No matter what, in all scenarios, the thing you want to do is make sure that water is not getting to the concrete, but it is protected by a waterproofing system. And when that system's in place, it'll make sure water gets to the drains. So hoping that we are also maintaining drainage and making sure drains aren't clogged, there's no ponding of water. And then finally, just letting staff and management know what to look for in these garages and what can be done. If they see something, make sure that they are letting those people who need to know so that you can get qualified eyes in the garage to take a look and make a formal assessment, which Rand is more than happy to do. And now I'm going to throw it back over to Michelle and see if we have any questions that have come up throughout our presentation. If you do have any questions, we will be here for a few more minutes, more than happy to answer them. But yeah, please, Michelle.
Yeah, thank you, Jason and Jimmy. Yeah, I've been keeping an eye on the chat to see if any questions came through, and we did have a few very good questions. The first one is, with the increasing number of electric vehicles that weigh double the weight of conventional gasoline vehicles, what are the implications for existing parking garages?
That's a good question. Basically, we always go by the code, right? Building code tells us that the live load required for a garage that's not subject to truck traffic is 40 PSF, which might sound a little low. But that's probably something that, really the national organizations that are writing codes are going to have to study to see if there's, any change in that guidance, what the design loads are. We as engineers, we stick to the code. The code tells us what to do. This is not about, our opinion, us trying to, figure things out that, haven't been studied enough. We try to keep it pretty, pretty tight to, code requirements. But I think that's, it's an interesting point in terms of, maybe that needing to be adjusted at some point because the average vehicle is heavier than it used to be.
Right. Thanks, Jimmy. The second question was, or is, could stainless rebar be a more efficient way to address these water damage issues versus the multi-layer concrete waterproofing top slab construction?
I think you're going to see that in new construction. Stainless is the way of the future. We're getting rid of epoxy coated. Rebar is on its way out. Even galvanized rebar, they're prone to damage. Most of the state DOTs out there are doing stainless. So stainless rebar is coming more and more. But that again is for new construction. It will help a lot. There's also a significant premium to that, trying to specify stainless steel rebar on jobs. If you see that it costs 5 times more, a lot of owners fight that. But it would be a limited, help in a repair. If you have an existing slab, tens of thousands of square feet, thousands and thousands of feet of rebar. Generally, we're not going to swap out the rebar to go with stainless because it would just be an enormous project. You'd basically be rebuilding your garage inside. So the best tool that we have for these existing garages is the coating, and we've seen it. We've been in garages that have had coatings in them for the last 20 years. So we're able to compare the performance of those systems to the ones that are uncoated. And it's a big difference. That's why we're, we don't own stock in Sika, but it's a noticeable effect that we think is really worthwhile for owners to spend that money. And it is an investment. The coatings cost, I think we're at like $20-30 a square foot, something around that. So, you might have $1 million of coating if you don't have a coating now, but in our opinion, it's a worthwhile investment in your structure.
Okay. The third question we have is it possible to have a pre-inspection completed before cycle deadlines so budgeting can be planned?
Yes, that is definitely something that we can do. We do, we call them parking structure evaluations. We can perform an evaluation of your parking structure and, create a budget for a potential repair program. Because this program is, cycled with windows, the later windows that haven't started yet do have the opportunity to even perform a repair program before their window opens and file a safe, have a safe filing submitted once the repair program is done. So, we're running into kind of every situation with our clients, but it is definitely possible to have us take a look and, give you an idea of what we're seeing and the types of repairs that would be required. And we can even, move into a repair program if possible. The other thing I want to emphasize is if there are concerning conditions, there's no reason to wait for your cycle. Certainly you want to address anything that is legitimately concerning as soon as possible.
Great. Thanks, Jason. And the last question we have here is how lengthy is the process from signing a proposal to submitting all the paperwork and then its approval?
We're typically looking at about 8 weeks for that. So if you're looking at, the end of the year, December 31st, unfortunately, one of the things DOB has done here is put the deadline on December 31st. So a lot of people are not working that week. It is similar to FISP in that you need not only the QPSI to sign and submit the form, but the representative from the building, their DOB now email address is actually needed. It is part of the report and they need to sign in, pay the filing fee, and sign the report as well. So it is about an 8-week process, but if you are thinking about getting in before the deadline is probably going to be difficult for some because that's a particularly difficult week.
Yeah, and of course that 8 weeks is when we submit the report. We have no control over DOB if they decide to take 2 days or 2 weeks to review that. And then we have to go through the objection process, right? So, and again, a little bit out of our control. We try to keep these tight. We don't want objections. We want them to accept the report the first time, but they always come up with something, and so then there's a back and forth that has to that we have to go through there.
Right. Thank you everyone for attending. If you have any further questions, please don't hesitate to contact Jason or Jimmy at their contact info on the screen. Thank you again for coming, and we hope you have a wonderful rest of your day.